Hey everyone, and welcome. We are surrounded by all this amazing, invisible technology that's constantly reading our world. So today, we're going to pull back the curtain and see exactly how it all works.
Oh, you know that sound, that simple, satisfying beep at the checkout. It feels so instant, right? Almost like magic. But in that split second, what is actually happening? What's bridging the gap between the physical groceries in your cart and the store's computer? Well, that beep, that swipe, that scan, they're all made possible by this incredible family of tech. The technical term is semi-automatic data collection devices. A bit of a mouthful, I know. But really, you can just think of them as these unsung heroes, constantly translating our physical world into digital data.
All right, so let's dive in. In this explainer, we're going to break down how these hidden helpers actually work. We'll look at 5 key pieces of tech, and we'll group them into 2 main methods: reading with magnetism and reading with light.
And trust me, you've definitely used all of them, probably without even thinking twice about it.
Okay, let's start with magnetism. This whole method is about reading information that's completely invisible to our eyes, because it's all encoded in these tiny magnetic particles.
So, think about it. How does that simple plastic rectangle in your wallet, your credit card, your hotel key, how does it hold all that info? I mean, there are no visible numbers on that dark stripe, yet it securely holds your account data or unlocks your door. How does it do that?
The answer is the magnetic stripe reader. That dark stripe, we call it a mag stripe, is basically a tiny piece of magnetic tape, just like on an old cassette. It's covered in millions of microscopic iron-based particles.
And the way it works is just brilliantly simple. When you swipe the card, a tiny electromagnet, that's the reader head, passes over all those little particles. It detects their unique magnetic alignment, reads that pattern like a secret code, and bam! It instantly converts it into your data. It's super simple, super fast, and yeah, remarkably effective.
Okay, so that's great for one card at a time, but let's scale this up, like way up. Think about banks. They have this monumental task of processing a sea of paper checks every single day. We're talking billions a month. Swiping each one just isn't going to cut it. They need something way faster, way more robust.
And the solution they came up with is just brilliant. It's called MICR, which stands for Magnetic Ink Character Recognition. Yep, this is the tech behind those funny-looking numbers at the bottom of a check.
Here's the secret sauce. Those numbers, the routing number, the account number, they're printed with a special ink that has iron oxide in it. So a machine first zaps the check with a magnetic field, which magnetizes the ink. Then a reader detects the unique magnetic signal coming off the shape of each character. Get it? It's not reading the look of the number, it's reading its magnetic footprint. That makes it incredibly secure and really, really hard to forge.
So the big takeaway on the magnetic side is that the readers are sensing invisible magnetic fields. Now let's totally switch gears. We're going to move to a different kind of reader, one that relies not on what it can feel, but on what it can actually see.
All right, now we're entering the world of optical readers. Instead of feeling for magnetic fields, these devices use light to see, to interpret everything from simple lines to complex letters.
And here we are, right back where we started, the grocery store. Remember the old days? Every single item needed its own price tag. It was slow, it was a mess, and it was full of errors. The problem was huge. How do you track and price millions of unique items efficiently?
You already know the answer, of course, the barcode reader. It works by shining a light on the barcode and measuring how much of that light bounces back. See, the white lines reflect a lot of light, the black lines reflect very little. The device translates that on-off pattern of reflection into a number, which the computer then uses to look up all the product info. And this wasn't just a small convenience, it was a revolution. The barcode literally transformed retail and logistics, creating the efficient global supply chain we all rely on today.
Okay, barcodes are awesome for machine-printed labels. But what about information that we humans create? You know, how can a machine rapidly process thousands of multiple-choice tests or survey forms that we've all filled out with a number 2 pencil?
Well, this is the job of optical mark recognition, or OMR. It actually works on a really similar principle to the barcode scanner. It shines a light on the page, but instead of reading lines, it's looking for the absence of reflected light in very specific spots, right where you filled in a bubble. A dark pencil mark absorbs the light, which tells the machine your answer. And hey, this is exactly why they always told us to fill in the bubbles completely. Okay, we're almost at the top of the mountain here. OMR can see if a mark exists in a certain spot, but it can't read. It has no idea if that mark is an A or a B. For the final, most complex task, Turning a whole physical document into editable digital text, we need something much, much smarter.
And that something smarter is optical character recognition, or OCR. This is the magic that powers all those apps that can scan a document with your phone. It's the systems that read license plates on the highway, or the services that digitize entire libraries of old books. OCR software analyzes the image of a character, compares it against a huge library of fonts and letter shapes, and makes an intelligent guess as to what letter or number it is.
And this is the perfect way to understand the difference. OMR is asking a really simple question. Is there a mark in this box? Yes or no? But OCR is asking a much more complicated question. Based on this pattern of pixels, what letter of the alphabet is this? So you can think of it like this. OMR sees where a mark is. OCR understands what a character is.
So, we've looked at magnetism, we've looked at light. What's the big picture here? What's the key takeaway from all of this?
And here it is, your complete field guide to the invisible tech that's all around us. You've got the magnetic side with readers for cards and checks, and then you have the optical side with readers for barcodes, test bubbles, and full-on documents. Each one is a specialist, right? But they all share the same fundamental goal. Because when you really step back and look at it, you see these devices aren't just gadgets. They are the essential, high-speed translators that connect our messy, physical, analog world to the clean, structured, digital one. I mean it, without them, modern commerce, banking, logistics, it would all just grind to a halt.
It's all data that's been hiding in plain sight. And now that you know how to see it, I'll leave you with this question. From facial recognition to RFID tags, what other forms of invisible data collection are being built all around us, right now? And how are they going to shape the world of tomorrow?